All right, let's dive in. Today, we're tackling one of the biggest, most important topics out there, climate change. We're going to break down the science, the evidence, and where we go from here. So let's get right into it.
First things first, we have to get a really basic idea straight. You hear the words weather and climate thrown around all the time, sometimes as if they mean the same thing, but they absolutely don't. So what is the real difference? Here's a great way to remember it. Think of it like this. Weather is your mood today. It's temporary, it changes. Climate is your personality. It's the long-term, predictable pattern over years and decades. So a single heat wave isn't climate change. Climate change is a fundamental shift in the entire planet's personality. And just how much has that personality shifted? Well, since the late 1800s, the planet's average temperature has gone up by about 1.2 degrees Celsius. Now, I know that might not sound like a lot, right? But in planetary terms, that tiny number represents a staggering amount of extra energy being trapped in our atmosphere, oceans, and land. And that really gets to the heart of the issue. We're not just talking about things getting a little bit warmer. We're talking about a fundamental change to the planet's entire operating system. It's a deep, systemic disruption to how everything works. To get why this is happening, you have to understand the greenhouse effect. Now, this is a totally natural and, frankly, essential process. Gases in our atmosphere act like a thermal blanket, trapping just the right amount of the sun's heat to make Earth livable. The problem isn't the blanket itself. The problem is that human activities are making that blanket way, way too thick. And here's something that might surprise you. This isn't some new idea. Our understanding of this has been building for more than 150 years. As far back as 1856, a scientist named Eunice Newton Foote first theorized that more CO2 would mean a warmer planet. From there, generations of scientists have been adding pieces to the puzzle, proving it time and time again. So, the big question, how do we know for sure that we're the main cause, and it's not just some natural cycle? Well, scientists have become a bit like forensic investigators, looking for specific clues or fingerprints that point directly to the culprit. Let's look at one of the most powerful clues they've found. This is the smoking gun right here. See, greenhouse gases trap heat low down in the atmosphere, warming the part where we live, the troposphere. But because that heat is trapped below, less of it escapes to the layer above, the stratosphere, which actually causes it to cool. Now, if the sun were getting hotter, you'd expect all the layers to warm up together. This specific pattern, a warming bottom and a cooling top, is the unmistakable fingerprint of the greenhouse effect. And to really grasp the scale of this change, we have to look back in time, way back. By drilling deep into Antarctic ice, scientists can analyze tiny air bubbles trapped thousands of years ago. What they found is that for at least 800,000 years, CO2 levels naturally went up and down, but they never went above 300 parts per million. Today, we've blown past 420. We are literally in uncharted territory. So what happens when you trap all that extra energy and push the atmosphere into a state it hasn't been in for almost 1,000,000 years? Well, the whole planet is put under an incredible amount of stress. And just like a person under stress, it's starting to show symptoms all over the place. Get this, over 90%. That's how much of all that extra heat we've trapped has been absorbed by the world's oceans. Think about that. The oceans have basically been acting as a giant heat sink for us, but it's coming at a huge cost, driving massive changes beneath the waves. As the oceans get warmer, the water itself physically expands. You add that to the meltwater pouring in from glaciers and ice sheets, and you get sea level rise. But look at the chart. It's not just rising, it's accelerating. The rate has more than doubled in just the last few decades, and that's a direct threat to coastal communities all around the world. And the impacts just keep cascading through the whole system. We're talking more frequent and much more intense heat waves, glaciers and Arctic sea ice disappearing at an alarming rate. This puts huge pressure on our food and water supplies. And at the same time, all that CO2 being absorbed by the ocean is making it more acidic, which threatens marine life from the bottom of the food chain all the way to the top. Okay, I know this all sounds pretty daunting, and it is, but this is not a diagnosis without a treatment plan. The world's response to the climate crisis is basically a two-pronged attack, and it is absolutely critical that we do both of these things at the same time. So on one side, you have mitigation. That's tackling the root cause of the problem, slashing greenhouse gas emissions to stop the warming from getting worse. And on the other side, you have adaptation. That's managing the impacts that we can no longer avoid, the ones that are already happening. You can't just do one, we have to do both. So if we're going to mitigate, where do we focus? Well, the data couldn't be clearer.
Look at this chart. The overwhelming majority, we're talking nearly 3/4 of all emissions, comes from how we produce and use energy. Electricity, heat, transportation, that's the big one. That is the core of the problem.
So it follows that the heart of mitigation, the absolute center of the solution, is a global energy transition. It means we have to move and move quickly away from burning fossil fuels like coal, oil, and gas, and move toward clean, renewable sources like solar and wind. And of course, becoming way more efficient with the energy we do use. And at the very same time, we have to adapt. This means things like building stronger, more resilient infrastructure, like seawalls and upgraded power grids. It means getting better early warning systems for storms and floods to save lives. It's about changing how we farm, using crops that can handle drought. And it also means protecting nature, because healthy ecosystems like forests and wetlands are one of our best lines of defense.
Because ultimately, here's what the science really tells us. The future isn't set in stone. The choices we make right now about our energy, our communities, our planet, are going to determine the kind of world that future generations inherit. The climate of the 21st century really is in our hands. The only question left is, what future are we going to choose?